Today we're talking about parallel lines. Parallel lines are coplanar lines that do not intersect. And what we mean by coplanar is they are in the same plane. So if you had like a piece of paper and you drew two lines that did not intersect, those would be parallel lines. Now skew lines are two lines that are not on the same plane that do not intersect. So for example, if I had on a cube, I could have this line here that is not on the same plane as this line here, but those two lines would not intersect. Now, a transversal is a line that intersects two or more coplanar lines at different points. So if I had two lines and then they intersect with another line, this would be a transversal. Right there. So if we look at some angles formed by transversal, we have two lines that are coplanar. The transversal is the line that intersects those two lines. Now, if we have two angles that are on the inside of our two coplanar lines and alternating sides of the transversal, these are alternate interior angles. If we have two lines and we have a transversal that intersects these two lines, if I take two angles on the exterior of these lines here, this would be the interior. Out here would be the exterior. We are alternating sides of the transversal on the exterior of our two lines here. So these would be angle 1 and angle 8 would be alternate exterior angles. We could also use these two angles as alternate exterior angles. Corresponding angles lie in the same position on the same side of our two lines with a transversal. So 1 and 5, they're both in the upper left corner. So they would be corresponding. We could also have corresponding lines that would happen here and here. Or we could have these two purple dots would be corresponding. We could also have the green dots here. Green and green would be corresponding angles. Then the last one is the same side interior angles. So we have our two lines here. Here's our transversal. 3 and 5 are both on the same side on the interior of our two lines here. Okay, so in the diagram below, we're going to identify the transversal. Our transversal is the line that goes through the two other lines, L and M. And then we're going to identify all angle pairs of the given type. So alternate interior angles. So we are looking on the interior of these two lines here, and they're alternating sides. So 4 and 5 would be alternating sides. We also have 3 and 6 would be alternating on the interior of the lines. Alternate exterior, if I have my two lines here, we would be alternating sides of the here's the transversal, so we'll be alternating sides on the exterior. So this would be 1 and 8 would be one example. 2 and 7 would be another. Same side interior, we're going to have our parallel lines. We're going to have two angles on the same side of the transversal. So 3 and 5 would be on the same side on the interior, and 4 and 6 would be another pair. Corresponding are in the same position on the same side. So I'm going to take my two angles. Let's do the upper left. Upper left would be 1 and 5. The upper right would be angle 2 and angle 6. The bottom left would be corresponding. That would be 3 and 7. And the bottom right would be angles 4 and 8. Those would be corresponding angles. Now on example 2, I have two pieces that are here. My transversal is going left to right, so it's just kind of been rotated around. But we're gonna have the same position. So we have our upper left would be 1 and 5. Upper right would be 2 and 6. Those would be corresponding. Bottom left would be 3 and 7. And bottom right would be 4 and 8. So I'm kind of doing this out of order. Corresponding would be what we just talked about. Angle 1, angle 5. Okay, let's talk about alternate interior. Here are our two lines. The interior is going to be in here. So we're looking alternating sides on the interior. So here's the interior. And if we're alternating sides of the transversal, that would be 2 and 7 and 4 and 5. Alternate exterior, here's our two lines. Exterior would be on the outside of the two lines, and we're looking for alternating sides. So here's our transversal, here's our two lines. We're alternating sides on the exterior of the line. So we're going to have 1 and 8 and 3 and 6. Same side interior, we're looking on the interior of the two lines. The interior on the same side would be 2 and 5 or angles 4 and 7. Okay, our first one is the corresponding angles postulate. So if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So 2 has to be congruent to 6, 4 has to be congruent to 8, 3 has to be congruent to 7, and 1 has to be congruent to 5. So since they're parallel lines, the corresponding angles have to be congruent. Okay, so let's look at alternate interior angles theorem. I like to think of these as kind of like an ice cream sandwich. If you take and cut the ice cream sandwich, what happens is you have, that's going to be your transversal. The inside of the ice cream sandwich is the interior of the ice cream sandwich. Everything on the outside of the ice cream sandwich is the exterior. Now let's pretend that we were going to cut one of these with a knife and make like kind of a cut through it. Okay, our next one is alternate exterior angles. If I take and I have my two ice cream sandwich pieces, I cut them with a knife, my two alternate exterior angles are going to be congruent. So this is kind of a big angle and a big angle, and then the corresponding, they're vertical, so they're going to be the same. And then the corresponding angle to that big angle is here. So this angle has to equal to this angle. So they are alternate exterior angles. Here's the interior, here's the exterior, and we're alternating on the exterior of the ice cream sandwich. So 1 and 8 are going to be congruent, and 2 and 7 are also congruent. The next one is alternate interior angles. And alternate interior angles are they're both on the inside of the ice cream sandwich pieces and they're alternating sides of the transversal. And those are actually also going to be congruent. So if we have here and here are vertical angles, the corresponding angles are congruent. So these two would be the same. And so all these alternate interior angles are also the same. So angle 3 and angle 6 are going to be congruent, and angle 4 and angle 5 are congruent. And since this is a figure, we're going to use this symbol congruent instead of the measures. But the measures would be equal if you had an angle in there. So here we have the ice cream sandwich. We're going to cut it with a knife here. These angles here are going to be the same side of the interior, and so are these. They're both on the same side on the interior of the ice cream sandwich. So that would be like this one right at the very bottom. So these are same side, 3 and 5 are same side interior, and 4 and 6 are same side interior. And the same side interior angles theorem say if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So if you look at this, if I were kind of going to draw this into a pie, these two angles are vertical angles. Those would be the same. And then these bigger ones are also the same. Now, if you have corresponding angles, this angle has to be the same as this one. And since they're on a straight line, these are supplementary angles and they add to 180. So 4 and 6 are not equal, but they add together to equal 180. So if you see inside, inside the two same side interior, they're going to be supplementary. And remember, I can make supplementary means I can make it into 180 degrees. They add together to equal 180. So let's do some proving of why this is true. Alternate interior angles theorem. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So our given is we have two parallel lines and they're cut by a transversal. So our given is M is parallel to N. And if M is parallel to N, angle 2 has to be congruent to angle 6 by the corresponding angles postulate. Now we also know that angle 2 is congruent to angle 3 because they are vertical angles. And so by the transitive property, angle 3 is congruent to angle 2, and angle 2 is congruent to angle 6. We can make a little train, and so that we can say that angle 3 is congruent to angle 6. And this would be by the transitive property. Now, this next proof is very similar. We are given that M is parallel to N. And since M is parallel to N, angle 1 is congruent to angle 5 by the corresponding angles postulate. We know that 5 is congruent to angle 8 because they are vertical angles. And since 1 is congruent to 5 and 5 is congruent to 8, angle 1 has to be congruent to angle 8 by the transitive property. Okay, now let's use what we've learned to figure out these angles here. Okay, let's look at example 5. We have 98 degrees here. Angle 3 is also 98 degrees. So we're going to have, these are corresponding angles, so they are also going to be the same, 98. And 2 is vertical to 3, so this is also going to be 98 degrees. Now, if I take 180 degrees and I minus off the 98 degrees, this is going to give me 82 degrees. So I'm going to take angle 1 and angle 4 are both vertical angles. So they are the same, 82. Angle 4 and angle 8 are corresponding angles, so those are going to be the same at 82. And 5 is vertical to 8, and so this is 82 degrees as well. Okay, looking at number 6, I have a straight line here, and two angles that are right next to each other on the straight line add up to 180. So if this is 80, that number 6 would have to be 100 degrees. Now we have parallel lines. Corresponding angles are equal. So 2 and 6 are corresponding. So angle 2 has to be the same as angle 6, which is 100 degrees. And 80 and angle 4 are also corresponding. They are going to both be 80 degrees. 1 and 4 are vertical angles. Vertical angles are always the same. So angle 1 has to be 80 degrees as well as angle 4. And angle 2 and angle 3 are vertical angles, and so they are also the same. So angle 3 is also going to be 100 degrees. Okay, let's look at number 7. First thing I want to look at is we have parallel lines here. These two angles are the same side. Here's our transversal. They are the same side interior. Now these ones are a little bit different. So if I have same side interior, these are not equal. They are supplementary. They add to 180. Now if I look at this, I have 50 plus y has to equal 180. So all I need to do is minus 50 from both sides, and y is going to equal 130 degrees. So 130 degrees for y. We have here, we have two parallel lines. I'm going to extend it out to help us. But if I have alternate interior angles, they are not supplementary. Those are equal. So x has to be equal to 120 since they're alternate interior angles. So this is x would be 120 degrees. Okay, number 8, we have two parallel lines and a transversal. Now remember, same side interior, they are not equal. They add to equal 180. See, this is a smaller angle than this one here. So I'm going to take my x plus 40, and that's going to equal 180 degrees. So I have x plus x, I have 2 x's plus 40 equals 180. I minus 40 from both sides, and that's going to equal 140 degrees. I divide by 2, and 140 divided by 2 is 70. So x has to equal 70. So this angle would be 70 degrees. And down here, 70 plus 40, that would be 110 degrees. So let's look at this other angle here. We've got this angle and this angle. They're both in terms of y. They are also same side interior, so those are going to be supplementary, which means they add to 180 degrees. So 2y minus 15 plus 3y equals 180. We're going to add the like terms together. If I have 2 y's and I add 3 more y's, I have 5y. 5y's minus 15 equals 180. Let's add a 15 to both sides. That gives us 195 equals 5y. I divide both sides by 5. So y is going to be 5 39. Now we want to figure out what each angle is as well. So if I took 3 times 39, that's 117 here. I could take 39 and times it by 2 and minus 15, or I can take 180 and minus 117. And that would be 63 degrees. Now, if I took 39 times 2, and minus 15 from that, I'm going to also get 63 degrees. So either way you do it, you always get 63 degrees there. On number 9, I have parallel lines. These are corresponding angles. They're on the same side in the bottom left corner. So those are going to be equal. So you have to kind of know whether you're going to set them equal to each other or you're going to add them up to equal 180. So these ones are equal. So we minus 2x from both sides. Let's add 27 to both sides as well. And so x is going to equal 20. I can plug that in. 20 times 2 is 40. Minus 7 is 33 degrees. And on the bottom, 20, 40, 60 minus 27 is also 33 degrees. So those would both be the same angle there. I have parallel lines. So these are corresponding angles. They're going to be equal. Wait, they are not corresponding angles, sorry. These are parallel lines. They are the same side on the interior of the parallel lines. So if you notice, this is a smaller angle, this is a bigger one. They are not equal. They're going to add to equal 180. So I'm going to take my first one, 2x. Then I'm going to add my second one, which is x minus 30, and that's going to equal 180 degrees. So x plus 2x is 3x, minus 30 equals 180. Add 30 to both sides. That's 210 degrees. Divide by 3. So my x equals 70. So 2 times 70 is 140. It's 140 degrees. And 70 minus 30 is 40 degrees. And if I add those two up, I do get 180. 140 plus 40 is 180.